So, Heinemann Higher, exercise 1O, question 8. You're given the equations of three sides of a triangle, you'd find the three vertices. Well, that just means you've got to do three pairs of simultaneous equations. However, before I start with that would be the general case. If you just were given three equations or made up three equations at random, they should intersect like this in three distinct points and form a triangle. It could be, though, that two of the lines happen to be parallel, and then the third one would come along and cross them, so you'd only have 2 points of intersection. You'd have two parallel lines if they had the same gradient. The third number would be different in the equation, but if they've got the same gradient, that means the ratios of x and y's would be the same. It could be that all three lines were parallel, so there's no points of intersection. Or it could be that the two of the lines aren't parallel, so they cross at a distinct point, and the third line also crosses at the same point. That would be the case where the three lines are concurrent, to share the same point. Only one point can be shared between any two lines. The way to find that point of concurrency then would simply be find where any two of them cross and then just check that the third one also goes through that point. So it'll just be check that it fits the equation. Right, back to this. Points of intersection. So I'll just find them. So vertex 1, I'll call it. So for vertex 1, any pair you like. Well, that's perfect for substitution, so I'll just substitute that into that. So I'll say substitute 1 in 2, in which case what I'll have is equation 2 with 1 written in its place. So 8 times, instead of y, 7x minus 6, then finish off equation 2 minus 5 equals 3x. Only one variable, so it can be solved. So what's that? That's 56x minus 48 minus 5 equals 3x. You can take it all together in one go. So that'll be, take that across and that'll be 53x. That also comes to 53, it's minus 53 there, bring it over 53, so x is 1. And then substitute x equals 1 in obviously number 1, since that's simpler, in which case number 1 would read y equals 7 times 1, minus 6, so y equals 1. So you've got that vertex 1, we'll just call that V1, so V1 is the point 1, 1. Same with the next one. What about vertex 2? Vertex 2. Just use a different pair of equations like 1 and 3, because I can still do substitution. Substitute 1 and 3. So that means equation 3 is going to read 10x minus 9 times, now as soon as you come across y, that's going to be 7x minus 6. It's going to equal negative 52. So that's 10x minus 63x plus 54 is negative 52. So here then I've got negative 53, there's that 53 again, negative 53x equals, take that across, that's a negative 54, so it's negative 106. That's fine because that's just two of them, so x equals 2. And then substitute x equals 2 in 1, which means 1's going to read 7 times 2, take away 6. So that's going to be 14, so I've just done it straight off, 14 take away 6, so y is going to be 8, which means the second vertex is going to be 2, 8. Oops. Then, vertex 3, I'll have to use 2 and 3. Now, none of them is suitable for substitution, so it'll have to be elimination. They're not quite right for elimination because they're not in the right order. So I think I'll try and rearrange that into the form of xy number, the same as the one over there. So that I'll write, for number 3, I'll take the 3x over and make it negative 3x plus 8y. And to make this look at the same as that, take the 5 over, equals 5. I'll call that 2, and then leave that one alone. 10x minus 9y equals negative 52. And that's number 3. And then I'd rather multiply by 10 and 3 than 9 and 8. So I'll eliminate x, eliminating x. And the plan for that would be, I'll have 10 of them and I'll have 3 of them. So 10 of them is easy. Negative 30x plus 80y is 50. 3 of them, 30x minus 27y equals negative 156. Adding them up so that that'll disappear. Well, there's that 53 again. 53y equals, that'll be negative 106, so y is going to be negative 2. Then substitute y equals negative 2 into whichever one's better to find x, probably the bottom one, keeps it positive. So that means this would read 10x minus 9 times negative 2 equals negative 52. So that's 10x, maybe I should just look chain with plus 18 equals negative 52. So that's going to be negative 70 then. So x equals negative 7. Oh, there was a lot of lines just to get down to that. Which means V3 is the point negative 7, negative 2. Only one thing left to do, and that would be, maybe I should have checked at each stage, is just double check those with the other ones. So that for the first vertex I used equation 1 to get this y, so check those two in equation 2. 8 minus 5 is 3, that works. I used equation 1 to get this, so check them in equation 3. Check 2 and 8 in equation 3. So you've got 20 minus 72 is in fact negative 52. And the same here. Oh, I'm not getting that one. I used number 3 to get that, so check it with number 2. So you would have 21 minus 16 is in fact 5. So that would be all correct. Right, done.